Covalent bonding tutorial. Covalent bonding is typically explained as a bond that forms when atoms are sharing electrons. In this tutorial, we'll explore what this means and how the process of sharing electrons can hold two atoms together. Answer the first question. Before we start explaining how covalent bonds work, let's experiment with two atoms that will form a covalent bond to see what happens. In the box below are two hydrogen atoms. When we move them around, we see that as they get close, they attract each other, and the two electrons, one from each atom, bounce back and forth across both the atoms now. Before you continue, be sure you know the answers to the following questions. How is the movement of electrons different when the atoms are close? And what happens if you try to move the atoms very close to each other? When they're close, the electrons bounce back and forth between the two atoms. But if you try to move the atoms very, very close, they won't get closer, and the second atom will just move away to keep the same short distance between them. Answer the next question. Let's look at what's happening in a couple different ways. I'm looking at an image where a line has been added showing the attraction of the nucleus to its own electron. When another nucleus with its electron comes close, we begin to see the nucleus on the left weakly attracting the other atom's electron too. When the atoms get even closer, the nucleus has a strong attraction for both its own electron and the electron from the other atom. Both atoms are attracting both electrons. We can see that the electrons spend almost all of their time between the two nuclei. Answer the next question. If we also show the attractions from the other nucleus, we can see that both atoms are pulling on both electrons. This is a covalent bond. The atoms are not really sharing electrons as much as they are fighting over them. They're both trying to attract the same electrons, but neither one can actually take them away from the other. This creates a situation in which both atoms are pulled together. Answer the next two questions. Let's take a moment and look at what kind of atoms will form covalent bonds. In which region of the periodic table would you find atoms that attract electrons strongly? Non-metals at the upper right side of the periodic table are good at attracting electrons. A covalent bond forms between two non-metal atoms. Answer the next question. Each atom attracts each electron. This pulls the atoms together. Note that hydrogen is considered a nonmetal, and it will form covalent bonds with the other nonmetals. Now let's look at the covalent bond from another point of view. How is energy involved in the formation of a covalent bond? I'm going to move the nucleus of one hydrogen atom slowly closer to the other. The closer they get, the potential energy goes down and down and down until they are a certain short distance apart. Then the energy spikes up really high if you try to get them closer. So the low point is close when the atoms are close, but not too close, not touching. Answer the next question. Okay, so as the atoms move closer, the potential energy decreases. This is because each nucleus is attracting the other atom's electron more and more strongly. After a certain point, the potential energy increases if you try to move the atoms any closer. It's because the protons in each nucleus are repelling each other. When the atoms are arranged so that the potential energy is at a minimum, they're at the most stable balance between the attractions and the repulsions that are occurring. The distance between the atoms at this point is called the bond length. Answer the next question. The point where atoms are lowest in potential energy is where they're the most stable. In other words, they are more stable when they are bonded together than when they are apart. Answer the next question. You'll find this idea is repeated in other areas of chemistry. Lower in energy means more stable. When we draw pictures of molecules, we often use a single solid line to represent the pair of electrons that are being shared. Answer the next question. Some atoms will form covalent bonds by sharing more than a single pair of electrons. Oxygen atoms, for example, share 2 pairs of electrons when they bond. We call this a double bond. It represents a total of 4 shared electrons. Answer the next question. Nitrogen atoms share 3 pairs of electrons to form a covalent bond. We call this a triple bond. It represents a total of 6 shared electrons. Answer the next question. Okay. Use what I'm about to say to answer the last question. Single bonds tend to be the weakest of the covalent bonds. Next stronger are double bonds, and triple bonds tend to be the strongest. Okay, that completes the covalent bonds tutorial. So please submit all your answers when you're done.